So starting off, the rest of the chapter will all be focused on quadrilaterals. Where's your packet?
I was moving forward so that I didn't look like a bad student.
But you need to have your stuff out. So quadrilateral, four-sided polygon. That's all we need, right? Okay. All right. We're going to learn parallelograms, rectangles, rhombi is the plural for rhombus, squares, and trapezoids. Okay?
A rhombus is like.
Yeah, don't worry about that now.
I remember what a rhombus is.
Today,
Is a rhombus.
I like rhombus.
I like
we're only going to work with parallelograms today. All right? Okay, so first we'll start with the definition of a parallelogram. First of all, has to have four sides, so it's a quadrilateral. Both pairs of opposite sides are parallel. Think about the term parallelogram. Parallel, right? So it's a polygon with opposite sides have to be parallel. Here, we have these two sides are parallel and these two sides. And we'll use the abbreviation. So just like we have triangle, we'll use that as our abbreviation for a parallelogram.
What's a gram?
Like it's a.
Isn't it also a measure?
Like parallel is like this. So what's a gram?
What kind of question is that?
It's like
Okay.
What's the root? See, you're not the teachers.
But it's not one question.
It's not relevant. Okay, I didn't make the names up. Here we go. Here are our theorems about parallelograms. Okay, notice these are all going to start off the same. So so we don't have to write it out every time. If you have a parallelogram, then opposite sides are congruent. So I just write the little symbol for parallelogram implies opposite sides are congruent. So these two are congruent and these two are congruent. Are all four congruent to each other? Not necessarily. They could be,
Sometimes.
but that would be a sometimes, right? So if I said all four pairs of sides are congruent in a parallelogram, that would be a sometimes.
Well, that could happen.
It could happen. It doesn't have to.
So you're saying that. So that means all of the opposite sides. Any sides that have an opposite side across them are.
They have to be congruent. We already know they have to be parallel.
When you draw that parallelogram, that sign, is it like it has to be that diagonal thing? Or can it be no square?
If you make it and it looks like a square, it's okay. It's not a big deal.
Why didn't you?
Okay, I did. That's why we moved the desk forward. Okay, next one. Parallelogram, opposite angles are congruent. Okay, so when we think of opposite angles, right, think of the ones that are diagonal to each other. So here, these two angles are congruent, and the other two are all four congruent to each other. Sometimes it's not necessarily, but hi, welcome. All right, next one.
Are you going to make proofs on the test?
Yes.
No.
So if we have a parallelogram, consecutive angles are, what supplementary add up to?
180.
180, good. So I'm going to use some angle measures here. Let's say this is 125. When we talk about consecutive angles, we think of angles that are next to each other, like right next to each other. So if this is 125, this would be 55.
Congruent, then that.
Right, so if we looked at the other consecutive angle, this would also have to be what? 55. And then we can see
125.
this would also have to be 125. So we have opposite angles are congruent, but consecutive angles are supplementary. Okay. All right, next one. If we have one right angle, so if it's a parallelogram and there's one right angle, what happens with all of them? Right, because consecutive, if this is 90, this has to be 90, these have to be 90, so all the way around. So if we have a parallelogram, again, all of this is starting out with a parallelogram. You got one right angle, all four. Okay, next one. Parallelogram, Diagonals bisect each other. Which part? Parallelogram? Diagonal?
It just looks weird.
Okay, well, that's how you spell it. We're just going to have to go with it. All right, let's draw the diagonals. Okay, now, diagonals are not congruent to each other. They bisect each other. So what does that mean?
So they split them in half perfectly.
Perfectly. How do we mark that?
90.
Not 90. These two are congruent and
Like a kite.
these two are congruent.
Why do they always just stand back there?
That's what they do.
More often.
I'm sure your parents did that back in the day too. Maybe. Unless you have an older sibling, then they didn't do it for you probably. Okay, diagonal also separates a parallelogram into two congruent triangles. So I'm going to just draw one diagonal. And let's go ahead and, well, this is something, all of these theorems are really, really easy to prove, and we're going to prove not all of them, but we'll prove a few of them. I did say chapter 6 is the last chapter that we're going to have actual proofs on the assessments. Okay, now hold on, we're not done with this one. What two triangles would be congruent here? Oh, hold on, somebody. Yeah, what did you say?
DBC and
DBC. Okay, it can't start with D.
Oh, DAC, DBC, and BDA.
DBA. Actually,
Do we agree?
yeah.
BDA.
It's got to be BDA.
So what?
And if we drew the other diagonal, then the other two triangles would be congruent to each other.
Wait, no, BCA? BD.
No, BDA.
P.
Good?
Oh.
Okay. All right. Okay, we're going to have a lot of the proofs with parallelograms are going to go back to getting triangles to be congruent. Okay, so if we can get triangles to be congruent, then their corresponding parts of congruent triangles are congruent, also known as CPCTC. Okay, Ariel?
Can we use the consecutive angles or supplementary for this one? Just solve it in one.
Okay, so we're proving the theorem, so we can't use the theorem to.
Just
Well-
use the supplementary angles, then.
Okay, so let's start with making two triangles. What are we trying to prove? We want to prove AB is congruent to CD,
In this case, is
We-
the given literally just that ABCD exists?
that it's a parallelogram.
Uh,
Okay, so we're trying to prove opposite sides are congruent, and we're also going to try to prove angle A and angle C are congruent. So what I'm going to do is I'm going to draw segment DB to make two triangles. Yeah, you can. If you want to put in a postulate, you can say DB and say,
why do we want to put an extra step?
you don't need to. Okay. Now, if it's a parallelogram, I'm only going based on the definition. No, I can't. I'm not using any of the theorems that come later. If I'm trying to prove the first two theorems, all I can use is the definition of a parallelogram. So, what's the definition of a parallelogram? The opposite sides are parallel. So, can you identify two sides that are parallel here? Okay, so I'm going to write AB is parallel to DC. And my reason is definition of parallelogram. And I will give you an updated theorem list. Just a minute. Okay, just a minute. I will give you an extra, we'll have an updated one. I'll bring that maybe next class. All right, now I have the other pair, AD and BC.
Is that also definition?
Yeah, so I'm going to put it underneath the same reason. Now, if I can get those two triangles to be congruent, then their parts are all congruent. I don't have anything congruent yet. I just have stated that they're parallel. But what does parallel lines give us? Like corresponding, alternate interior, alternate exterior, all of those special angle relationships. And this one specifically will be using alternate interior. So this angle, so angle ABD has to be congruent to this CDB or BDC, it doesn't matter. D has to be in the middle though. So this is alternate interior angles theorem, right? Goes back. We also have reflexive. Let's do the other two alternate interior angles first. So these two. So I could put that under the same reason. So this will be ADB is congruent to angle DBC. So basically so far I have two pairs of angles. Now what? I think I heard reflexive. So DB congruent to DB. We're almost done.
This is a long. You said these are easy to prove.
Yeah, but it's like all review.
Yeah. Just so
Okay?
long.
It is. It's just we haven't done them specifically with a definition of a parallelogram. Now, once we prove this, now we can use that theorem and any proof after this.
Was last
So,
chapter the only one without proofs?
yeah, so far.
No, in the whole year.
Well, we didn't really have proofs in chapter 1. We have proofs in
You
chapter
know
2.
what I mean.
Okay,
Like, the
since
rest of the
chapter
year, Are we
2.
gonna have another chapter where there's no proofs?
Yes. This is really the only one that we have proofs on it.
Oh.
Okay? So, what triangles are congruent? ABD or ADB, doesn't matter, but you have to make sure we match it on the other one, so it would have to be CBD. We need a reason. Side, 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 angle, angle, side, angle, angle, side, angle, good. And now we're done, right?
Now you need a proof.
So we just need to write in, what are we proving?
All those sides.
All of those things are congruent. Running out of space here. So C, P, C, T, C. We didn't understand what? Yeah, that's fine. Okay. Next theorem we want to prove are diagonals bisecting each other. Oh, they're supposed to have segment lines above. Minor detail. Okay. So, first statement is that we have a parallelogram, ABCD. Okay. I want to prove AE is congruent to EC and BE is congruent to ED. So, what two triangles are we wanting?
We need to include the diagonal AC and BD.
Nah, don't worry about that. That's just one. So, if I can get, BEC? Yes. If I can get this triangle BEC and this triangle congruent to each other, so kind of ignoring these two other sides, if I can get those two triangles congruent, then I can prove CPCTC.
Well, they're parallel.
Okay, they're parallel.
Use vertical angles.
We can use vertical angles theorem, and
Alternate.
we can also, so we could do alternate interior angles theorem, we could use vertical angles, and we can use, what was the one that we just proved? Opposite sides are congruent. So what should we go with next? It doesn't matter, there's no wrong.
BC is congruent.
So BC is congruent to AD. The reason is parallelogram implies opposite sides congruent. Okay, I have one pair of sides. I'm going to label that.
Now opposite sides parallel.
Okay, so I can also say AD is parallel to BC. That's definition of parallelogram. Okay, so now if I say they're parallel, now I can use alternate interior angles theorem. What angles are congruent? Okay, so like kind of opposite of each other. Actually, let's list the other two sides too here. Or actually, no, we don't need to. We just need those two. So these two angles are congruent. So angle DAE is congruent to angle BCE.
Yes.
I know, the lettering gets kind of confusing here.
We have one more.
We have one more. We could do these two. So angle ADE congruent to angle CBE. Do we have enough congruent statements? We have 1, 2, 3.
We do angle side angle.
Angle side angle. Now remember, if you have any of these on the homework, you can use the theorems to save some of the time. So we're going to say triangle.
You just do the ones from like right up there. The angles.
Yeah, I'll just use ADE and CBE. And so we can say AE congruent to CE and BE congruent to ED. We know the ones with CP, CTC end up being a little bit longer, so we're not just getting the triangles to congruent. That's the end of it.
Yeah, they make these.
Don't you have to change here? Yeah.
Going back to the first step.
The first step.
For the first step, number 2, how do I know that BC is congruent to AD?
Because we just proved that theorem above.
It's not a regular polygon.
It's not a regular polygon, it's a parallelogram.
Okay. Aren't all you can have parallelograms that aren't how do I know that they're congruent?
Because that's a theorem that we had just proved above.
In this case, if you make up, so I can see the.
We just proved opposite sides are congruent. That's
That's really difficult.
right here.
Are they're only congruent
It's
because they're
the
opposite?
second one,
Who?
or the first one here.
How do I know that they're opposite?
Can you like
We weren't given any angle.
I'm doing the recording.
How do we know that they're opposite?
Well, they're not.
Because like DAB and BCD could be different angles.
What do you mean? These are opposite sides in the parallelogram, so they have to be
But
congruent.
how do we know that?
Because it's a theorem that we just proved.
But by looking at it, how do we know that they're opposite? Because like the angles could be slightly off, and then
No.
they're not.
Oh, stop trying to break that up.
Oh, we knew that. Yeah.
The sides that are parallel are the ones that are opposite.
How do we know that? Does it say that they're parallel? How do we know it's parallel?
Oh my goodness. This is what you get for working on your homework during the notes. We're moving on. Okay, let's do the next one.
No.
So, XYRZ is a parallelogram. And WZ is congruent to WS. Okay, so
It says parallelogram. It does the square. Yes?
sometimes. Okay.
To make life easier, couldn't you do a diagonal cuts that they're all triangles?
We don't know that they're all going to be. So these are parallel and these are parallel. And then we also know WZ, so this side, it's kind of hard to label it though, is congruent to this side, which makes that an isosceles triangle, the big one. What am I trying to prove?
That
X.
angle is congruent to an angle.
So I want to get this angle congruent to this one. Okay.
Wait, which angle?
That
This one here
Oh,
and this one here.
so
Okay.
small.
Now I've mentioned something about it being an isosceles triangle.
The base angles are congruent.
Base angles are congruent. So I can say
Oh, and then
The
angle
side-
Z.
opposite angles, and then
This one we don't have to prove any triangles or there's no triangles congruent in this
I
one.
know, so it's
You could
gonna
just
be a
do-
lot
oh.
easier for angles.
This is isosceles triangle theorem. So the isosceles triangle theorem says if two sides are congruent, then the base angles are congruent. And then the converse would be if the base angles are congruent, then that makes the
No,
sides.
then you have to do the angle x, y, or
Okay.
angle Z.
Yes,
Yeah, and then
because
opposite
opposite angles are congruent. So angle Z,
And then you do like
Angle.
Property. Transitive property.
so we need to say it's a parallelogram, which implies,
No, after.
yes,
You're
after.
ahead of me, Eden.
I'm sorry.
You're behind.
I'm sorry.
Sorry.
Oh, I wrote it
Right,
fine.
so we have angle Z is congruent to angle S, angle Z is congruent to angle XYR. So by transitive,
The reasons for the parallelograms, it's not even English, it's just like drawing.
okay. Transitive property.
What?
Nothing.
I'm doing this.
Okay. Okay.
No, Will.
Okay, I was zooming out. Relax.
Do we have a class? No. Nice.
Oh,
That's mean. No offense. So mean.
And taken. Okay.
No, but C period is a better, actually.
SV is congruent to what?
SV is congruent to VQ.
VQ. We need a reason.
Divide all angles, diagonals bisect.
Good. So in a parallelogram,
That one.
diagonals bisect each other. Sorry, I know there's not a lot of abbreviating for this one.
just make abbreviations like
Nope. Okay, angle SRQ. SRQ is right here. That has to be congruent to what angle?
STQ.
STQ. Okay. Opposite angles congruent. There, we got some abbreviations there. QT.
RS.
Nice. QT is congruent to URA.
Well, like all of these.
That was just way too fast.
Yeah. So parallelogram implies
Opposites.
opposite sides congruent.
Did you think that out of the spot?
Yeah.
Oh, it's the same one again.
Okay, oh, this is a triangle though. So triangle SRQ will be congruent.
Yes.
Q, what's the next letter?
I was just confusing. Just trying to take it back now.
Wait. S?
Yeah, TS. And this is, I'll just say two congruent triangles in a parallelogram. That's all. It's just, I could say the diagonal. I'm going to abbreviate that one.
Two congruent triangle parallelogram.
That's
so
fine.
Weird.
Okay, TSR. TSR is this angle.
Okay.
Now we actually have two different options here for it's got to be supplementary to.
it could be SRQ or ST.
Yeah, it could be SRQ or angle STQ. And this one is in a parallelogram. Consecutive angles are supplementary.
Plus over. Denver's warm.
Okay, now I mentioned it was pages 5 through 8. We're on page 7, which means turning over.
The last one.
Page 8 is the last one.
You know the eight things? Oh, the eight handles?
Yeah.
Near mine.
Yeah, you touched that.
Right intentions, right actions, wisdom, view,
Oh.
Yeah. Okay.
food,
Effort.
MJK up here has to be congruent to what?
MLK.
MLK, which is a
100.
combination of 30 and 70, so that's got to be 100,
On the test stage, I'm looking less.
Jimbo.
right? So we know this whole thing is 100. JML, that's this angle.
80? It's
Got to be 80 because consecutive angles have to be.
JKL is also 80.
JKL is also
She posts online.
80.
You could also just she posted online.
KJL.
30.
Oh my god, it's hurt.
What did we say? 30?
Yes, Liam, we get it.
Okay, how about A?
A is
Where is
7.
it? Where is A?
7.
It's on the left.
7.
It's the side.
Oh, yeah.
We have 3A and 21.
That's what I was saying. I was like, there's no way you would have known.
A is 21.
Yeah, completely. I knew you wouldn't understand what we did.
So 2B equals 42, so B equals. Okay.
Why are you writing down the side? Oh.
You would have been shocked.
Check.
Okay, good.
Go.
Last one. Okay, we have QZRQ is a parallelogram and WQST.
Can we draw an arrow like Alex did?
Oh,
We should have a class where Alex teaches.
What did you say?
We should have a class where Alex teaches.
Oh,
Can me and Justin teach? Hey, I'm fine with Prodigy teaching, but you were a stretch.
okay.
Yeah, you draw an arrow. That's fine.
So we have VZRQ. So I'm going to trace that. So this one and this one. Why am I tracing it? Why do you think I'm tracing it?
Distinguish between the two,
So we can distinguish between the two, right?
because they're on top of each other.
Right, they have some overlap.
wait, no.
Okay, if they're, we're trying to prove Z is congruent to T. What angle do they have in common?
Oh.
That's why I traced over it.
Angle WQR.
Isn't it Q?
Is that Q? But
WQR.
isn't it just the
WQS.
WQ, we could just call it angle Q.
because it's using for both.
Okay, so what's angle Q have to be congruent to?
Angle
Why don't we just try to prove the parallelograms?
Angle Z
Angle Z
and angle T, right?
and angle T.
How many sides do you need to prove it congruent? Like we're trying
Can you run it back?
SAS,
This case I'm confused.
SAS.
No, we don't need any of that.
What's the one for? But what if I want to? What if I want to prove them?
There's no
congruent?
triangles here.
I don't know. What if I want to prove parallelograms congruent? How do I do that?
You need to show their sides are congruent.
All of them?
You get me?
Yeah, both pairs of opposite sides
How
are
do we know
congruent
that
and the
Q
opposite
and Z are congruent?
angles.
Oh,
Because it's a
they're
parallelogram.
Oh, yeah.
Do you see it?
Yeah, that makes sense.
Yeah, and then it's just
easier 'cause
transitive.
There's so much overlap in this case.
I know, but you have to look for the actual angle.
What's transitive?
You were actually the one to answer the reason why.
There's only one angle that they both share.
Wait, it's over?
Just like that.
Just like that, the proof is done.
Wait, is it actually?
That's so good.
Actually.
It's too good to be true.
So this case is